right, let's talk amines. Amines are without doubt the smelliest functional group we have. And by smelly, I mean not just like, oh, that kind of stinks. These things are gross. For example, the names of these particular diamines I've drawn here are putrescine and cadaverine. You don't need to know these names, of course, but this is perhaps the most obvious property to us when we are working with amines. They stink. One of the worst smells I know, I've not had the luck of smelling putrescine and cadaverine. I don't think I would want to, but triethylamine, a very common base that we use in organic chemistry, smells very much like rotting fish combined with ammonia. So ammonia has that very sharp, pungent smell. It's used for cleaning. You've probably smelled ammonia, a couple times in your life. And then I'm adding rotting fish and putting those two smells together. So it's very strong and very just disgusting. So that's our introduction to amines, right? So these nitrogens happen to react with us biologically to be very, very stinky. So much like sulfur, right? So of course, amines are phenomenally useful in biology, right? All of our bodies are made of amino acids forming proteins, as well as our DNA has significant amine proportions. So we are only alive thanks to amines. Lots of drugs, of course, use amines. Methamphetamine, of course, is a very common amine that we think of when we think of drugs. But I mean more pharmaceuticals often have amines in them. And so we'll see that they're very common biologically. So we'll study them. And we're going to split this chapter up into two. We'll have kind of the synthesis side of amines and some properties, and then we'll have the reaction side, and that'll be next week. So, the wonderful world of amines. Here we go. Amines, as we see here, are these nitrogen-containing compounds. Specifically, we can have what are primary amines, secondary amines, tertiary amines, or quaternary ammonium. Quaternary. So, for example, a primary amine would have 2 hydrogens and some R group on your nitrogen. A secondary amine has got 2 R groups and 1 hydrogen. A tertiary amine has 3 R groups, no hydrogens. And then a quaternary ammonium has 4 carbon-containing units, 4 R groups. And we're going to see that, of course, that would make the nitrogen positively charged. We often see quaternary amines. They are fairly stable. So we do see these much more than we would see something like a carbocation. We can isolate quaternary amines. A very easy example is ammonium chloride. Very easy to isolate this. You can buy it as a powder. Ammonium nitrate, that's a fertilizer, or an explosive, whichever way you want to look at it. So quaternary amines are often very stable. And of course, if you have 3 hydrogens, that's ammonia. That's a special case, right? It's like a methane, right? A methyl carbon, just having CH3, and then whatever is your X on it, like methyl bromide. Ammonia is just NH3. As we see here, we have a lone pair on the nitrogen, which will be very important when we discuss its properties. We also see that primary, secondary, and ammonia, primary amines, secondary amines, and ammonia, all have hydrogens, which means that these can engage in hydrogen bonding, which typically will put their boiling points and miscibility with water, how much they mix with water, around that of alcohols. They're a little bit less. Alcohols have stronger hydrogen bonds than amines do, so alcohols mix better with water. Alcohols also have higher boiling points than amines do. But they are kind of still, with that hydrogen bonding allowed, they're higher, much higher than just alkanes or ethers or something like that. So we have some kind of physical properties there. We also see that the primary, secondary, and tertiary amines, as well as ammonia, all have that lone pair on nitrogen. And we're going to see very often nitrogen-containing compounds will act as bases. And, we're going to look at that as well. So that will be another big section. So we'll kind of skip that for now and we'll come back to it. And we'll do that this week kind of in the properties section before we even talk about reactions, even though basicity is technically a reaction. So let's talk about geometry. Amines are not chiral. Chiral centers, that is, at most temperatures. The reason for that is because if you have, say you've got an amine with a particular spatial relationship between its R groups and its lone pair, right? Lone pairs count as something. So if we have four different, or if our three R groups are different from each other and we have that lone pair, that's four separate things. We have an sp3 center. That means we have the conditions for chirality. All right, so normally we would expect, yes, amines to be chiral. However, they will very easily flip over. This is a very energetically easy process at most temperatures, where you'll have this kind of amine inversion. So suffice it to say, amines undergo rapid inversion, and so they themselves are not chiral centers. So on the nitrogen itself, we don't typically consider that chiral. However, amines can be chiral substituents on carbons. For example, this would be a chiral compound, and the chiral center is this carbon. However, if we have something like this, our amine is not a chiral center. It has a lone pair, a methyl group, an ethyl, and a sec-butyl group. However, even though those four groups are all different from each other, and it's an sp3 hybridized atom, we do not consider that amine to be chiral. So we only have the asterisks as chiral centers in these molecules. All right, so that's kind of our introduction of just amines in general. We'll talk about some properties, and then we'll talk about how to name them as well in future videos.